So the next example goes like this. As I said, it has distributed weight, and we can imagine a cable that weighs 200 pounds. So let's write a 200 pound and 100 feet long cable vertically hangs from the top of the building. The top of a tall building. Okay, and the question is how much work is required to lift the cable to the top of the building. Okay, so even though I didn't write it, I said that, remember, the bottom of the cable is above the ground. So the whole cable is hanging in the air, like so. So this is the tall building, and let's say the cable is hung down like so. So this is the cable. Okay, so we don't know how tall is the building. We really don't care. You know that the cable is 100 feet long, like so. And we want to find out the work that required to lift the whole cable to the top. Okay. What we do, as we did before, because the cable is distributed, the weight of the cable is distributed every piece of it. We'll just take a piece of it. How small is the piece? You can think that it will be infinitely small piece, so we call it dx. X will be measured from here. This will be x equals 0, and let's say this will be x equal 100 this way, okay? So, and this will be dx. So we know that now we need to figure out what will be the work that is required to take this element of cable a distance of dx. Okay, so what is the weight of the cable? Well, we know that it has a total weight of 200 pounds, but it's distributed over 100 feet. What we can do, we can find out what is the weight per foot, right? And the weight per foot, or the distributed weight, we have 200 divided by 100, 200 pounds, divided by 100 feet, like so, and we're looking at 2 pounds per foot. Okay? And this is the force, if you think about it. Remember, the force that applies to dx, to the price of an element of weight, the force will be this is weight divided by foot, so the force will be 2 times dx pound. Okay. We have the force and the distance that will go to go from here to the top is what? X. No. We don't know the position of these dx. We picked up this dx at random. Okay? We know the weight of this little element, or the force or weight. So this is the force of an element dx. It's 2 dx. And now the distance to the top equal x. So dw will be the force, which is 2 dx times x. Okay, so this is force and this is distance. And we can rearrange it as 2x dx. And now we have dw, and of course w will be the summation. And the summation, remember, we need to sum all over the cable, and the cable goes from 0 to 100. So it will be the summation from 0 to 100 of 2x dx, like so. And we come up with, this part is easy, we come up with 2x squared, right? Evaluate from 0 to 100, or 100 squared is 10,000, so we're looking at 20,000. 2x squared, just x squared, right? That's what you're yelling at me? Yeah, you're right. So it's 10,000 foot per pound. Okay? I think it's good time to close the class.